Hey there! Welcome to this introduction to coding terminology. If you're just starting out with programming or looking to brush up on the basics, you're in the right place. In this session, we're going to break things down in a simple, easy to understand way. We'll cover essential coding concepts, walk through the software development process, and explore how coding is applied in the real world. So sit back, relax, and let's get started.
This training is part of the EU-funded Code4Future project. The project is coordinated by Gent GmbH in collaboration with L4Y Learning for Youth GmbH and Seyhan Danışment Gazi Anadolu Lisesi. Stay tuned for more coding content from this initiative. You can find more resources through the link provided in the description.
By the end of this lesson, you'll have a good grasp of 1. Understand essential coding concepts. 2. Comprehend the software development process. 3. Explore practical applications of coding. Let's start with the basics. What is coding? Coding, also called programming, is the process of creating executable computer programs that achieve specific outcomes. In simple terms, it's how we tell computers what to do. When we code, we write, test, and debug instructions that computers follow to perform tasks. These tasks can be anything from running a website to controlling a robot or even making a video game. Learning to code opens up many opportunities. You can build your own applications, automate tasks, or even start a career in technology. With the digital world expanding rapidly, coding has become a highly valuable skill. Computers may seem complex, but at their core, they perform just 2 fundamental tasks. 1. Performing calculations. At their most basic level, computers are powerful calculators. Even the simplest computer can process billions of calculations per second, making them essential for everything from solving math problems to running advanced simulations. 2. Saving the results. Once a computer performs a task, it needs to store the results. A standard laptop or PC can store the equivalent of millions of books, keeping information accessible for future use. This storage allows us to save documents, images, videos, and more. These 2 functions, calculating and storing, are the foundation of all computer operations, from running apps to powering artificial intelligence. Now that we understand the basic tasks of a computer, let's move on to next slide. Now, let's explore 2 major programming paradigms, declarative and imperative programming. Declarative programming is like telling your car where you want to go, but not specifying how to get there. The car, or system, figures out the best route automatically. It focuses on the desired result, not the steps to achieve it. Example, think of using a GPS. You enter a destination, and the system decides the best route for you. Programming languages that follow this approach include Haskell, Lisp, Prolog, and SQL. Imperative programming, on the other hand, is like manually driving a car. You don't just say where you want to go, you also decide how to get there, controlling every turn and speed adjustment along the way. This approach focuses on the steps and instructions needed to reach the goal, giving you more control over how the task is executed. Example, instead of using a GPS, you look at a map and plan your own route, deciding every action. Languages like Java, C++, Fortran, Pascal, and Python follow this imperative approach. To summarize, declarative programming focuses on what needs to be done. Imperative programming focuses on how it should be done. Both have their advantages, and depending on the project, one might be more suitable than the other. One of the first things people learn in any programming language is how to print "Hello World" on the screen. This is a simple way to test that a language is working and to get familiar with its syntax. Here, we see 4 different programming languages and how they print "Hello World." In Python, print "Hello World." In JavaScript, console.log "Hello World." In R, message "Hello World," then print message. And last but not least in Go, uses fmt.print println hello world inside a main function. Even though the languages look different, they all achieve the same result. This shows how every language has its own rules, but the basic logic stays the same. In programming, variables are like containers that store data. They allow us to save information and use it later in the program. For example, in Python, we can store an age like this, age *25. In JavaScript, we can store a name like this, let name Alice. This means that whenever we use the variable age, the computer knows it represents the number 25. And whenever we use name, it represents Alice. Variables help make programs dynamic and allow us to handle changing data easily. And that wraps up the first part of this chapter. I hope you found it helpful so far. But we're not done yet. There's more to explore. In the next part, we'll continue diving deeper, so be sure to check it out. See you there.